Well, so we're going to go over the third quarter quarterly exam, the multiple choice questions. In the first question here, you have 9x to the fourth minus 27x to the sixth. You have some common terms to factor out. You take out 9x to the fourth, we'll be left with 1 minus 3x squared. That is completely divided by 3x to the third. Since we're dividing, we can now cancel. 3 goes into 9 3 times, and x to the third goes in x to the fourth, just up with the next. Our final answer is 3x, parentheses 1 minus 3x squared, which looks like choice 2. In this next problem, you have 6 radical 20 divided by 3 radical 5. We know that 3 goes into 6 twice, and since the 20 and the 5 are underneath the radicals, they are able to be divided. So 5 goes into 20 4 times. So what we're left with is 2 radical 4. We know that radical 4 is 2, so it's 2 times 2, or 4. So choice 4. Next problem, we have a fractional equation. So, anytime you have a fractional equation, we're going to multiply the whole thing by the LCD. The LCD is what the denominators can become. All of them. They can all become 15. So we can distribute that 15 to each numerator. So we have now 15 times 2x divided by 5 plus 15 divided by 3 equals 15 divided by 7x minus 2, all divided by 15. Again, we do that just like we did before in order to cancel the denominators. 5 goes into 15 3 times, 3 goes into 15 5 times, and the 15s take each other out completely, and when they do that, they become 1s. So we have nothing in the denominator anymore. The numerator, we have 3 times 2x, or 6x, plus 5 equals 7x minus 2. It's a straight equation. So we use order of operations to solve it. We're going to subtract the 6x from each side because we're crossing the equal sign. We're going to add the 2 to each side because again we're crossing the equal sign. Leaves us with 7 equals x plus 4. In the next problem, it says which expression represents x squared minus x minus 6 divided by x squared minus 5x plus 6 in the simplest form. So in this case, we're going to factor the numerator and the denominator. X squared minus x minus 6, we know factors to be x minus 3, x plus 2. X squared minus 5x plus 6, factors to be x minus 3, x minus 2. We have to remember that we have to add to be the middle term and multiply to be the last term. Again, add to be the negative 5, multiply to be the positive 6. Once we do that, again, we're going to cancel, since we're showing multiplication, x minus 3 over x minus 3, and we're left with x plus 2 over x minus 2. Which will give us choice 1 as the answer. In question number 5, we have radical 72, and we know that radical 72 really means radical 36, radical 2, because we want the largest possible perfect square with a factor of 72. Radical 36 is 6, radical 2, and we're going to bring the 3 radical 2 along, since that's already in simplest form. 6 radical 2 minus 3 radical 2, since they both have the radical 2, we can combine them. So 6 minus 3 is 3 radical 2. Our next problem, we have 6 radical 50 plus 6 radical 2, and we know that 6 radical 50 is is really 6 radical 25 radical 2. Just like before, 25 is the largest perfect square. That's a factor of 50, which gives us 6 times 5 radical 2. Radical 25 is 5. So that's 30 radical 2. And the whole time we're going to bring along the addition of 6 radical 2. Because that is in simplest form. Since they both have radical 2's, 30 plus 6 is 36 radical 2. It's 4. Which ordered pair? Ordered pair is a solution point, is a point. A point is any xy pair. So what we're looking here for is any xy pair that's a solution to the system. A solution to the system means where they meet. So they meet there and they meet there. This point for us is -1, -2, -3. It's up 1, 2, 3, 4, 5. So this point is really -3, 5. This point is over 1, down 1, 2, 3. So it's 1, -3. When we look at our answers, I'm looking for either this point or this point to be in our answers. And I see -3, 5. Right there. Which is the value of the solution of x is a solution of. So you have a portion. All portions we cross multiply. So we have x times x plus 13 equals 5 times 6 is 30. We're going to distribute. Gives us x squared plus 13x equals 30. Since it's a quadratic, we're going to set it equal to 0 by subtracting the 30 from each side. Since none of the terms are like terms, we line them up. And again, in order to solve any quadratic, we factor. So we're looking for things that multiply to be -30, they add to be 13. We know that that's going to be 15 and a -2. We set each factor equal to 0 and solve. So that's with -15 and 2. That's no good, that's no good, that's no good, -15 was the answer that was shown. What is the sum? When we're looking to add two fractions, we have to make sure that the denominators are the same, and they are. If they're not, then we have to change them. Since they are, we don't. We can just add the numerators straight. So in this case, you have -x plus 7 plus 2x plus 5, all divided by 2x plus 4. I'll combine my like terms in the numerators. So -x plus 2 is x. 7 plus 5 is 12, divided by 2x plus 4. I have three terms here that have a 2, but one does not, so it's not factorable. Therefore, we're going to go with choice 1 as the answer of x plus 12 divided by 2x plus 4. Number 9, you have a system of equations, and we want to find that solution. Well, the first thing we have to do is we have to rewrite 2y minus 2x equals 10 into y equals mx plus b mode. Okay, so that means we're going to solve it for y. We're going to do that by adding the 2x to each side. So that gives us 2y is equal to 2x plus 10 and divided by 2. So that gives us y equals 1 over 1x plus 5. Can you see that? 1 over 1x plus 5. Let's erase that here again. Make that neat. So we're left with y equals 1 over 1x plus 5. There we go. So now the 1 over the 1 means it's a positive slope. That slope of this line is going downhill. no good. Going downhill, no good. This one's going uphill, good. Uphill, good. And they both look like they're touching the y-axis at 5, so it really depends on this quadratic. So what we're doing is we have to go back to this. So we're going to go to y equals in your calculator and type it in. You're going to type in x squared plus 2x plus 3. When we do that, we're going to look at our graph on our calculator. And this is the parabola, and this is the line. So therefore, we can clearly see that it's choice 1. Alright, which relation represents a function? Remember, your function, the word function, means that it has to pass the vertical line test. Which means that when we have anything on a graph, if you have any graph, it can only touch the graph at one point. That's good, that passes. That's a pass. But if you have a graph, and the graph is being able to touch the vertical line more than once, that fails. What happens here is, whatever the x value is, it has a y value, then it has the same x value with a different y value. And that's what makes it fail. So we're looking for the same x value with different y values. Okay, or the same domain with different ranges. So 0, 3, 0, 6, no good. Negative 7, 5, negative 7, 1, no good. 2, 0, 6, 2, 6, negative 2, no good. On the fourth, negative 6, negative 3, 1, 2, and 6, no passes. Now, last problem here. It says which equation is represented by the accompanying graph. When we see straight lines like this, we know that it's an absolute value. That's a quadratic. That's what we saw, that U-shaped curve. Right? So that's no good. So in order to do this one, we're going to type in our calculator, y equals, and then we're going to press math. We're going to right arrow down to number. And then we're going to hit the ABS button. Okay? We're going to open the parentheses, and we're going to type x, close the parentheses, minus 3, graph. If it looks like this, we're all set. If it doesn't, you're going to go back, do it again, and this time type in x plus 3, close the parentheses, minus 1. Check it out. Since this is 1 unit above, that means it's a plus 1. And that's where that plus 1 is coming in. So when we look at what I type in, we have absolute value of x minus 3, close the parentheses, plus 1 gives us this graph. And that's the best resemblance. Remember, the zoom is a little bit different from this. That's it. Good. Thank you.